this proportion stuff, it's where we have two fractions that are equivalent. So I like to just kind of draw in two fraction lines and an equal sign just to start out with. Now again, we should be comparing the same things, but they have to be in the same places. So for example, I mean they can be equivalent fractions like 3/4 and then like 6/8, something like this. But again, if we're not comparing the same things, then it's not really, I don't know, formal to write that they would be equivalent. Like if you had 3 dogs compared to 4 cats, and then suddenly you were comparing $6 for 8 hours. Well, the values of those are the same, but now they're not equivalent because we're not comparing the same things, right? So one of the common mistakes we see with these is that we see something like this. We use the same labels, but we put them in the wrong place. Yeah, very good. 6 cats to 8 dogs. Well, again, the values are the same, but they're not equivalent because it's not dogs to cats and then suddenly cats to dogs right there. But we have done problems like this before with just the equivalent fraction part, right? So if I said I had 1/2 and this was equal to, I don't know, some kind of tenths. You guys remember these types of problems, right? And then there was a box for the homework. So what number goes in the box? 5, right? Well, you do 2 times 5 to get the 10, 1 times 5 to get to the 5. So that's called a scale factor method, okay? This is using scale factors. Scale factors are not always convenient, which is okay. There's 2 other methods that we're going to show today, and you get to choose whichever one you like the best. But scale factors are legitimate. You can use scale factors all the time. Well, is each of these true?
Yes.
Looks like it, right? So here's what we can do is we can look at the unit values for these, right? We can take this and divide it by 12, and this divided by 12. Now, of course, you don't have to if you don't need to, right? But this would give us, well, 1 egg. And how many dollars is that? 0.25? $0.25 per egg on that first one. And over here, we're going to divide this by 18. 18 divided by 18, so that's, again, is 1 egg. 450 divided by 18, though, yeah, that's another 25 cents for an egg. So yeah, these are equivalent. So this is a proportion. Is each proportion true? Is each proportion true? Yes, this one is. Yep, so this one would be false, right? Again, if I divide both these by 8, then it's not really a rate here because we're not comparing 2 quantities. But we can still compare these. So what is that? 5.4 divided by 8. Yeah, thank you. 675. Over here, we'll divide by 10. That one's a little bit easier. So 0.68 to 1. Yeah, so our numerators are not the same. So these ones, is it a proportion? No. Is this proportion true? That's what it really is. No. I like 6. We'll get to number 6 because it's got that complex fraction. But on this one, number 3, see, it's kind of hard for us to determine right away what would we multiply 6 by to get 15. So I'm looking at scale factors, right? Now, since it may be difficult to figure out what that is, some of you guys know that you just do 15 divided by 6 to know. But in a way, we're kind of looking at making this 15 become a 6, or the 10. We're going to have to figure out what we'll do with that 10 in order to become an n. So the scale factor thing may not be as convenient on this one. So the next most common method that's used is cross multiplication. And to make the cross, we're just going to put a cross through that equal sign. Now, cross multiply indicates what operation we're using. We're using multiplication. So for the red portion here, this is 6 times 10. And it should equal the other cross as well. So this one is n times 15. Well, 6 times 10 is 60. And this equals, we may be a little bit more used to seeing this as 15n. Whether you keep it as n times 15 or not really isn't too important. As long as we know what to do next in order to solve this equation. There's no decimals or fractions, so yeah, we'll just divide by 15, right? And then this shows us, so I got a 1n, that's good. 60 divided by 15 is 4. Now we could check, just to make sure, right? We're saying that n is 4 right here. So in our calculator we could do 4 divided by 6, which equals 0.6 repeating, that's a horrible 0. And I could do 10 divided by 15 in my calculator, which is also 0.6 repeating. If these are not the same, then either we rounded, but since we didn't round on this one, it should be exact, those two values, with checking. All right, so here's the thing is we got 4 values on this. 1, 2, 3, 4. Now the way this works is we're going to multiply, divide, and then it's equal. All I got to do is fill in the blanks, okay? So this method, we always start with the unknown or the letter, the variable, whatever you want to call it. And we either go up or down like this. Now what we're doing there is making a tail. A tail of what? Well, you'll see. So that's first numbers that we ran into is what we'll put into that first value. Okay? Well, if I come up here to this next value and I cross it, then that's my next value in this series, 32. Now if I swing this back down here, then I have the 4, and then I just end back at the R. See how it created a tail of a fish right there? Fishy method. Yeah, people like fishy method. Some people like happy fish. Some people like happy piranhas. Some people like angry piranhas. You just never know, okay? But in any case, this is something I could plug directly in my calculator. And when I do, looks like I should get 88 equals R. So again, you do 11 times the 32, and then divide by the 4. So on this one, the variable, the unknown's in the bottom, so I got to go up to make the tail, right? So that first number is 49. I come down, I get my 9. I'm going to swing this back up to the 7, and then I end at my variable, which is what I want to know what it equals. And it looks like this one, if I put in my calculator, 63 is cubed. Okay. So once again, we got 4 values, 1, 2, 3, 4. We'll multiply, then divide. It's always multiply, then divide. And again, that process really comes from that cross multiplication stuff. It can come from the scale factor stuff as well. So I'll make the tail from x to 9. Then I drop here. Now this is a fraction, right? Oh, that's not 3. It's 2/3 there. And then I'm going to swing this back up to the 8. And I'll finish my fish off with an x. Some people call this bow tie method because you could make a bow tie if you want. I just like the fish, okay? Well, in my calculator, I can put this in. Of course, not everyone needs a calculator on this stuff, right? You could use 9/1 times 2/3, giving you 18/3, which is really just 6. And then we'd divide this by 8. And 6 divided by 8 should give us 3/4 as a fraction. If you found the decimal, it should have been 0.75. I'm okay with either one because they have the same value. In some of your guys' calculators, you may have to put this in parentheses. In fact, I advise it just in case, because otherwise it can get the order of operations mixed up there with what you really want it to do. Alright, 7 should work the same way. Let's try a fish method on this one. Multiply, divide, and equals. And from the end, I'll drop down to this 2 1/3. You know what? I'm going to change that to an improper fraction right now. I hate mixed numbers. So 2 times 3 plus the 1 is going to give us 7/3. And then I'll cross up here to 3.5, which would be 3 times 2 plus 1, 6 plus 1 is 7/2. And then we'll divide this by, because we're going to come back down to the 7, by 7. And would end up at the end. Alright, if we do this multiplication here, I got 7 times 7, which is 49. 3 times 2, which is 6. And then we'll divide this by 7, which should be 7/6. I don't actually know what that is in a decimal form. Let's see, 7 divided by 6. It's a pretty ugly decimal, 1.16, and would use bar notation to indicate that it repeats. One, two, three, 4 values, multiply, divide, equals. So, starting with the n, we'll create the tail, 8.7, cross to 0.2, divide by 0.4, and we'll finish off at n. Well, this is again something I can just plug into the calculator, divided by 0.4, I get 4.35 equals n. And yeah, that's a nice quick way to find the answer. Because on 9, for example, we got a recipe right there, right? That's something, I mean, if you've ever cooked anything before, usually you have some experience with this stuff. 6 ounces of noodles makes 3 servings. So that gives us a fraction there, 6 ounces of noodles for 3 servings. And we want to know how many ounces of noodles for 8 servings. Now again, we just need to make sure the labels are in the right place. Ounces are in the numerator, that's good, and then servings in the denominator. Now if we want, we can use an X for the unknown value for the number of ounces, and that would allow us then to use the fish method. 1, 2, 3, 4, multiply, divide, and equals. And I would go down to the 8, cross up here to the 6, bring that down to the 3, and finish off at the X. It appears that for this we would get 16, right? 16 ounces? Yep, for 8 servings. So how many ounces do we need? 16 ounces for 8 servings. Now you guys wouldn't necessarily need to write all that in there. We're more concerned about the 16 ounces than the rest of writing this as a sentence. So at 3 p.m. Michaela's shadow was 1.2 meters long. Michaela is 1.7 meters tall. Now it actually may help to draw a picture of this. So Michaela just gets to be a stick today. She's 1.7 meters tall, and the shadow she cast was, and that's not proportional, but 1.2 meters. Well, then she's got a tree. The tree should be pretty big there, and then it's casting a shadow that is 7.5 meters right there. And we just want to figure out how tall the tree is. So there's 2 things we're comparing here, and that's how we're going to set up this proportion. 2 things we're comparing is we have the height of the person and the shadow and the length of the shadow. So when setting these up, it just doesn't matter where they go right now, because we're not really looking for unit rate specifically. So do you want the height of the tree or Michaela's shadow do you want the height of the thing or the shadow, length of the shadow, to be the numerator? Because you get to choose. Alright, so let's say that the shadow values will be in the numerator, and then the height of whatever we're comparing is, I think I spelled that wrong. It's one of those days right now. So the shadow, let's look first at Michaela. Her shadow is 1.7 meters, while her height is 1. No, what the heck, man, see? This is just a bad day for me, man. 1.2 meters is the shadow, and her height is 1.7 meters. All right, I got to get it together. Now we got the tree. And the tree shadow is 7.5 meters. Yeah. And we don't know the height of the tree, but that's the value that we want. So this sets up the proportion. Now, just so you know, there are 8 different ways to set this up, and you could still get the right answer. For example, if we did height in the numerator, then we just would flip both of those fractions, okay? But we just have to make sure that we're comparing the right things in the right places here. So this allows us to set up the fish method. 1, 2, 3, 4. Multiply, divide, and equals. And I take x, go up to 7.5. That's my first value. Multiplied by 1.7. Come up to 1.2. And this closes off at x. I can put that in my calculator. By 1.2, and it appears that the tree, I got 10.625 meters. Didn't really tell us where to round there, so we'll just keep it like that. And again, that all came from this stuff right here. That's how I got that 10.625 meters. Recipe calls for 2 tablespoons of sugar for a batch that makes 30 pancakes. If you want to make a batch of 20 pancakes, how much sugar should you use? So, again, we'll set up a proportion on this thing, particularly where the fractions, again, it doesn't matter where we put these, either in the numerator or denominator, but what 2 things are we comparing here first? Yeah, right. Sugar and pancakes. So, which of those 2 do we want to be in the numerator and denominator?
Pancakes in the denominator.
Let's do it. So we'll do pancakes in the denominator, pancakes. And then we'll do the tablespoons of sugar in the numerator. All right. So first off, they did give us this comparison right there, right? 2 tablespoons for 30 pancakes. And then it said we're going to make a batch of 20 pancakes. So for 20 pancakes, how many tablespoons would we need? So we can use X there again. And that allows us to write fishy method 1, 2, 3, 4. Multiply, divide, equals. And using the fish method, I go down to the 20, cross up to the 2, come down to 30, equals X. When I do this as a decimal, I should get 1.3 repeating on this problem, but looks like that's right. 1.3 repeating tablespoons of sugar.
It's a fraction that equals 4/3.
Yeah. And the 4/3 is a lot easier to look at. Again, I'm okay with both 4/3 tablespoons. Yeah. A child that is 3.5 feet tall casts a shadow that is 7 feet long. At the same time, a building casts a shadow that is 42 foot long. So this one's kind of similar to that one with the tree. We got 3.5 feet. Whether you write this as a decimal or an improper fraction is not going to matter. So 3.5 or 7/2 feet. You get to choose. Well, now that we get to choose, which one do you guys want me to use? because it doesn't matter. Let's do 3.5. So we got two things that we're comparing. Once again, we got the shadow and then the actual height. Let's switch this one around just to show that we can. So I got height, H-E-I-G-H-T. Again, I may have spelt that wrong, but hopefully I'm close. And then we also have the length of the shadow. Well, this should help us set up the proportion. The height of the child is, we said would use 3.5. And the shadow is 7 feet. Yeah, we can label these in feet too. Whereas the building has a shadow that is 42 foot long. So we want to figure out the height of the building. So once again, we'll set up a fishy method. Multiply, divide, equals. And we'll draw the fish. So 42, 3.5, 7, and x. And putting this into the calculator, 21. Well, x represented the height of the building, so we'll just want to label this 21 feet tall. The following recipe calls for a ratio of liquid to fat to flour as 1 to 2 to 3. I was planning on doubling the recipe, but as I went to add the flour to the bowl, I was a bit short and only ended up with about 5.5 cups of flour. How much fat will I need to add? How much liquid will I need to add? Two separate proportions. Now, first up, we know that this one, wait, what the heck? Yeah, so let's identify that. We got 1 to 2 to 3. Now, I don't want to write the words out, but you can, because it all means the same thing. So it says liquid, so that's the first one. Liquid to fat to flour. So it's 1 to 2 to 3, liquid to fat to flour. And again, this should give us two separate proportions for this. So we got this fraction right here. And it doesn't really matter how we compare these. We can do, let's figure out this first one, okay? How much fat will I need? So I can do a comparison of fat to flour, which means that this one also will be fat to flour, okay? Well, right there, you're just using the ratio. It had 2 parts fat for 3 parts of flour. Whatever those parts are, tablespoons, cups, gallons, it wouldn't matter. But this allows us to fill in 5.5 cups of flour. So I'm just going to make that 5.5. And we just got to figure out how much, I guess that'd be cups of fat that we need. So, once again, using fishy method. And this one, again, just solves for the amount of fat that we need. How much cups? So I start at 5.5, cross up to 2, bring that down to 3, and finish off at x. So 5.5 times 2 divided by 3, I got 3.6 repeating cups of fat. So that's how much fat I need to add. Well, how much liquid do we need to add? So liquid, we can see there is 1 parts, and we only know, well, we started knowing how much flour. We do have the amount of fat now, but let's just start with what we knew. 3 parts for flour, right? So this means that in this new proportion, we got, we'll just say liquid to flour. So this one also is liquid to flour. Well, 1 part's liquid for 3 parts of flour, and we know that we have 5.5 cups of flour. So we'll solve for x this way. Once again, fishy method. Multiply, divide, equals. Drop down to 5.5. Bring that up to 1. Come down to the 3. And that solves for x. So 5.5 times 1 divided by 3. I got 1.83 repeating. Again, that's going to be in cups of liquid. Now, yes, once again, we did know how much fat we needed, and it's 1 part's liquid to 2 parts of fat, so you could have cut that in half, which should give you the 1.83 repeating cups of liquid.